Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on root mean square velocities. So let's get started. At what temperature does the root mean square velocities of hydrogen molecules become equal to that of oxygen molecules at 500 Kelvin, given that the molar mass of oxygen and hydrogen are 15.999 gram per mole and 1.008 gram per mole respectively? Alright, so the first step that we need to do in order for us to answer this question is to calculate the molar mass and convert it into kilogram per mole for each compound. Therefore, we are going to start with oxygen. So the molar mass for oxygen is equivalent to 15.999 times 2 because oxygen gas, right? So you will get 31.998 gram per mole. Right, so from here we are going to convert into kilogram per mole. So kilogram per mole. So how are we going to do that is we are going to divide this value 31.998 divide by 1000. So you will get 3.1998 times 10 to the power of negative 2 kilogram per mole. Right, so what we are going to do next is we are going to do the same thing for hydrogen gas. So the molar mass for hydrogen gas is equivalent to 1.008 gram per mole times 2 because you have H2. Therefore, you will get 2.0160 gram per mole. So to convert this, you need to divide into 1000. So you will get 2.0160 times 10 to the power of negative 3 kilogram per mole. So this is the first step that you need to do before we can proceed to the calculation by using the root mean square. Alright, so now we are going to plug in the values by using the root mean square. So it's going to be 3RT divided by the molar mass, but in kilogram. It should be equivalent to 3RT of the molar mass in kilogram because they said that it wants to be equal. So becomes equal. That's why we have equal sign here. Right. So what we are going to do next is just to plug in the value. So the value will be 3, the square root of 3. So your R is gas constant. Make sure that you use the correct one, 8.3145 kilogram meter square per second per Kelvin times mole. So this is the unit for R, and your temperature is 500 Kelvin. So now this one will be the molar mass for oxygen. So 3.1998 times 10 to the power of negative 2. Right? So next up should be equivalent to the same thing but for hydrogen, only that for the T here is what we need to calculate. So I'm just going to rewrite this so that it's easier for you to see. Alright, so before we start calculating, we just need to see the unit first. So we have kilogram here, we can slash out with here, and we do have mole, and we can slash out with this one as well. And this Kelvin can be slashed out with this. So same as this part. Alright, so leaving you with the rest of the calculation, which is the square root of 3.8977 times 10 to the power of 5. So you have meters square per second Yeah, that's about it. Is equivalent to the square root of 1.2373 times 10 to the power of 4. This one is a little bit different. Meter square per second over K, and then the T we just put X, right? So in order for us to remove this square root, I'm just going to do to the power of 2 for each side. Therefore, you will get your X, which is the temperature, is equivalent to 3.8977 times 10 to the power of 5 meters square per second divided by 1.2373 times 10 to the power of 4 meters square per second over Kelvin. Right. Therefore, you will get your X is equivalent to, we're just going to quickly slash this out. It's supposed to be Kelvin. So your final answer should be 31.502 Kelvin. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.